Okay, a little break there. What were we talking about? We were talking about trying to do single digit times double digit in our head. Is that what I want you to accomplish and do on my test? No. I don't care if you can do single digit times double digit math in your head. Although this might give you a tool about how to do it. You might be like, oh, wait a minute. This mental math thing, I just needed some suggestions. And here's a suggestion. So instead of trying to do 7 times 13 in my head, I broke the 13 into 10 and 3 because I know 7 times 10 is easier, even if your multiplication tables aren't. Great. 7 times 10 is supposed to be 70. And you get a nice estimate of what 7 times 13 might be sort of like, too. It's 70 and a little bit. Well, then your multiplication tables do come up because I put 7 times 3 on there on purpose because 7's about where people's limits sometimes are. They usually get up to 6s and then 7s get a little more difficult. It just takes practice. So if your multiplication tables aren't the greatest, get an app or something like that. Play with it while you're bored on the bus or something like that, or driving somewhere. It doesn't take long to get them so that you're not. I say to my kids, we don't have to have them super fast. You don't have to win any contests. But it's nice if it's 7 times 3, you can at least go and get the answer in a few seconds anyways. It'll help you in all the math that we do to be able to do that. Anyways, 7 times 3, do you have it? Did I give you enough time to think of it? 20. So then in your head, you're going, here's what it looks like when I do it in my head. 7 times 13, I go 70, 21, 70 and 21 is 91. Because I can do 70 plus 21 in my head, not too bad. Is there bad ones? Yes. If I had, instead of this, I had to put up 8 times 37, it gets a little hairy. Yeah? So I don't suggest practicing with those if you want to practice the trick. Practice with the friendly numbers until you have the trick down. This is called distribution. This is what's going on. This is how numbers work. If you got a number out front of a bracket with 2 numbers in it, you have to multiply the 7 times 10. Yes, you do. But you also have to multiply the 7 times the 3. That's what distribution's all about. It's turned into an algebraic magic trick. Oh, you have to distribute the 7 over, and it becomes mysterious or magic. It's not magic at all. This is how numbers work. If you want to multiply a number times another number, you got to multiply by each number. Each number gets a 7. You get a 7, and you get a 7. That's my motivating example. Here's what it looks like for you and your homework. Distribution. Review of prerequisite skills. Simplifying expressions. There's a number in front of each of these brackets, and that number means multiply. We don't want to have to write 5 times every time, so we just put a 5 out front and go 5 of these. You do that in normal language too. When I say 5 bananas, I mean 5 bananas. When I say 5 bags of groceries, I mean 5 times everything that's in the bag of groceries. So we use that shortcut all the time. And the way to remember to do this before you actually do it is to write a little arrow there. Did your grade 10 teacher draw a little arrow there? You were supposed to do this in grade 9 too, but it could be your grade 9 teacher didn't quite get to it. And when there's only a single number out front, well, 5 times x is 5x. That's not supposed to be that complicated. But then 5 times negative 9. Now that's mysterious, because if you had said this, you would have said that's x minus 9, and now I'm saying 5 times negative 9. So is this negative 9, or is it subtract 9? And the answer is yes. Okay. Oh, okay. Yeah, it feels good for me to say that. You're like, oh, it's not. If you want to think of it as negative 9, if that helps, good. If you want to think of it as subtract 9, good. So actually in this question it goes back and forth. When I read it, it's x minus 9. When I multiply it, I go 5 times negative 9, and then I write subtract 45. So it's subtract or it's negative depending on what you're doing, and that's okay. That's an algebraic okay thing. If you really want a deeper understanding of that, that really bothers you. It's usually about 2 people per class. They're like, I don't like it. You're going to have to do more there. What you really have to think about is this is adding a negative. So you're multiplying 5 times adding negative 9, which is adding negative 45, which is the same as subtract 45. So it's all legitimate. I'm not playing games here or making up stuff. It all works. Okay. Now, this time, what's out front is not 2, it's negative 2. You're like, no, that's subtract 2. Same trap I was just talking about, right? It could be subtract 2. Or it could be negative 2 if I'm multiplying. But this time I'm multiplying. So I think of it as negative 2. So negative 2 times x is negative 2x. And negative 2 times negative 6. Oh boy. Negative times a negative? Positive 12? Why is negative times negative positive?
The negatives cancel each other out.
The negatives cancel each other out. You're saying, okay, take away this negative stuff, which is the same as adding something on. Guys, done enough? You're in grade 11. Oh, maybe you haven't taken a good chemistry course yet. Who's in chemistry this semester? Oh, yeah. Chemistry gives you some good weapons here to think about. If you're taking away electrons, the charge is getting more positive. So that really helps in all this, to think of it that way. Good. That was good. Is it done? No. One of the most important things we can do is collect like terms. Put the things together that go together. We don't want these big messes of algebraic expressions. The word simplify is there for a reason. We want to make this expression easier to work with. Things are going to get out of hand here in 11U math, 12U math, calculus. Things are going to get out of hand. And what we need to do is try and simplify things as much as we can to give ourselves a chance at ridiculous questions. So what can go together here? 5 xylophones. It's the only word I know that starts with X, so we always use it when we're talking algebra. Xylophones. Subtract 2 xylophones. I can put those together. This expression is really saying 3 xylophones. And then negative 45 plus 12. Now, okay, again, is it subtract 45 or is it negative 45? And the answer is whichever one you need it to be. If I'm taking this term and putting it together with a term over there, I think of this as a negative. Some other people don't do that. They're like, oh, this is subtract 45, so it's 12 minus 45. That works too. Yeah, those both work. Negative 45 plus 12. I encourage you to try them in your head. Like, when you lean on the calculator all the time, you leave yourself open for mistakes. So in your head, like, I think it's around this much, and then type it in, of course. We like using the calculator. We got important things to do. We're going to use the calculator. We talked about calculators yesterday. If you got a calculator that you brought in today that you didn't have yesterday, check it with me. Now, why is this so important? When are we ever going to use this? Well, it's a bit of an exaggeration, but it's close. Have you ever downloaded a game or got the new iOS on your phone and things get a little glitchy or they slow down? It's because someone didn't simplify the algebra as much as they could have. And then you get like, they get iOS 15 and then you get 15.1. Somebody went back in the code and went, oh, too complicated. And they did something and tidied it up and made it more efficient. It's probably the difference between an Apple iPad and those $100 tablets you can get that do a lot of the same stuff. They're just a little slower. They're just a little glitchy. The Apple people simplify things down. It's a slight exaggeration. It's not exactly what's going on in the world, but it's close. That's what simplifying is all about. Let's make this thing faster and better. All right. Technically, that's a tough grade 9 question or a medium grade 10 question. That's what I would call that. This would be like, okay, let's ramp it up a notch. Let's deal with a whole bunch of different variables going on and see if we can juggle all those things at once. Give it a try. Take a shot at this. See if you can multiply the first set of brackets and collect like terms. And I'll try to be patient. If you're on the video, you can fast forward a little bit. Give them 60 seconds. If it's really too much for you, just wait. I'm going to do it. But it's good for your brain. I covered the microphone there so people don't have to listen to me drinking.
What's the number of the book here?
2, x squared, 3xy minus 4y squared. And these are the same variables, x squared, xy, y squared. Yeah? Not big enough? Better? Yeah. Make it bigger. And I'm going to make my pen smaller. Giant writing here. See if that's better. No, that's still big. Ooh. Okay, that was a minute. Does anyone want to tell me what they got out of the first brackets? That's not a pen. And you get to be on the video. You get to be on one of my videos on my website for eternity.
Like simplify. Oh, for that one?
Yeah.
Oh, my bad. I thought we were doing the top one.
Oh, yeah. No, this one is the one I want to work on now. That one I finished up.
Oh, I thought you were gonna like simplify it like more. You were like.
Can I? That's a good question. Let's go back to that. Can I simplify this anymore?
Yeah.
Can these go together?
Yeah, well, you do like 3 divided by. You divide them both by the.
Yeah. Okay. So I'm going to answer both ways. If somebody said, no, you can't simplify any further, I would actually agree with them. 3x minus 33, these terms don't go together. But that's not what you're going to do. You're going to try and factor it, right?
Yeah, like 3.
So I'm going to draw a line there. We do not have to do this just yet. We're going to do it. But this one actually happens to factor to this. Is that what you meant?
Yeah.
Ah, even better. Factoring is good. It makes the expression even simpler. But we'll get to that. That's not really what today's lesson was about, but I like it. I like it a lot. Yeah. How about the second one? Anyone have time to get me something on the second one? And you get to hear your name in the background. You can go home tonight and say, listen in the background. That's me talking, Mom, on the video. If the video works.
Okay, for the first bracket,
Yeah.
I got 2x squared
Correct.
plus 6xy
Love it.
minus 8y squared.
Absolutely. All he did was take the 2 and he multiplied by each term. Now, if there's no coefficient out there, life is really simple because it's just 2x squared. But there's another way to think about it. What coefficient is actually there? When I write x squared, what coefficient is actually out there?
1.
There's actually a 1 up there, so it's 2 times 1. So you're still doing the same thing, but you don't have to think of it that way. I don't think of it that way. I just go 2x squareds. Yeah? But here, I multiply the coefficients. 2 of these 3xy's. I got a 3xy. I got another 3xy. 6xy. So I just multiply the coefficients together. I don't have to distribute when I'm dealing with multiplication. It's only with addition. And then the final one, negative 8y squared. So the second bracket, if you got that, is negative 15x squared. Positive 10xy. If you wrote negative, don't panic. You're probably just out of practice a little bit. You know, to see the negative times the negative. It's going to drive you crazy in the homework. Negatives, it's always a negative. We have that saying in calculus a lot of time. It's always a negative. Yeah? Negative 5 times y squared, negative 5y squared. Am I done? No. And I don't know what your grade 9 teacher did. When I teach grade 9, I do something like this. I go, well, let's underline the ones that have the same variable part and underline what's out front too. That tells you what it actually is. This is not 15x squared. It's negative 15x squared, or it's subtract 15x squared. You can have it either way, but either way, I got to deal with that negative. So now putting those together, I get switch colors there. Negative 13x squareds, 6xy and 10xy. So then when I was teaching grade 9, I'd put a different kind of underlining like
Mr. Todd,
oh yeah,
is Marley Arctic in class?
I don't know. Yes,
Can she come see Miss Ronson?
certainly.
Thank you.
Out of the washroom.
I hope so.
You can just leave the number.
Oh, my bad.
You just leave.
This being adult thing is complicated. Look, I did crazy underlining like that. You're like, I don't need your crazy underlining. I can keep track. I'm like, things are going to get out of hand. So these are good little tricks to have to go, okay, lightning underlining for that one. And I don't have to underline the last one because it's the last one. So I'm going to do not underlining there. Negative 8 minus 5. Your brain's going to say positive 13. Well, I use temperature on this one. If it's negative 8 degrees out, won't we be sad? Remember, won't we be sad in December when it's negative 8 degrees out and we're thinking about this day that was so hot and we were complaining. Anyways, if it's negative 8 degrees and it goes down another 5 degrees, now we're down to negative 13. If you have trouble with integers, maybe you just need some examples to use. And I'll give you some examples to use. You're like, oh, wait a minute, these integers aren't quite so complicated. As long as you use the right example. Maybe protons, electrons, maybe temperature, help you out. You're like, I'm just going to rely on my calculator, thank you very much. Yeah, it's nice to be able to do them. All right, do you have any questions about that? Okay, just between you and I, not between the people beside you, give yourself a 1 to 5 on that. 5 is like, I can do these all day. I don't even know why you're wasting my time here. And 1 is like, this is the stuff I really struggle with. And I'm only asking so I know what to do next. To keep explaining my brains out, which I'm glad to do, but I don't want to bore you. Or to keep it about the same. You ready? You just hold it up on your chest, or no one else will see it. And I'll just look, don't look sideways. Don't be that guy or girl. Give me a number about how easy or hard that was. Most of you pretty happy? Okay. I'm not going to rush. I enjoy teaching. But this is a completely different question. It has some of the same algebra, but it's completely different. See, grade 9s usually hate these questions. They're unsatisfying. You get down to this financial, you're like, so that's it? That's all I do? Yeah, because of what it said. It said simplify. Simplify, just make it better, clean it up a little bit. But these ones are different. This is what we want to do. We don't really care about simplifying except to use it to solve. Solve is what we're really about. We want to solve equations. So we've got to do the simplification to solve this. So the simplification here is, again, multiply out the brackets on both sides. I'll do that for you because most people said they were pretty confident about this. 4x plus 8, and then negative 4x minus 2. But then I need some help. Whoa! My active board is it's acting a little wonky today. Slow down. Lift the pen. Ding, ding, ding-a-ling. Hopefully that's not too bad. I multiplied the 4 into the brackets on the left. I multiplied the negative 2 into the brackets on the right. But now I need some help. To solve this and find out what x is, can anyone have some words about what the basic strategy is here? What's the basic plan of solving these types of equations? What am I going to try and accomplish here? Isolate x. That's the big phrase they're supposed to have beaten you with a stick with that through grade 9 and 10. Isolate x, get x by itself. Usually on the left, and in fact your teacher might have been like, always on the left, but it doesn't have to be on the left. But usually move all the x's to the left. So I still use my trick. I go, okay, this stays, this moves. It's got to come over to the left-hand side. And when it crosses the equal sign, it changes operations. Whoops, getting ahead of myself. Do you see what my brain did there? I'm already predicting what's going to happen next. So I bring this negative x over, negative 4x, and it becomes positive 4x. The other ones, 6 and negative 2, stay over there on the right. But this positive 8, or this adding 8 moves over. And what's the opposite operation to adding 8? Subtracting 8. So when I bring it over to the other side, it becomes subtract 8. That's supposed to be the worst of it. That step's the one that really holds people up. X's to the left, numbers to the right. The rest of it is supposed to be not bad because 4x and 4x is 8x. And then 6 subtract 2 is 4. Subtract 8 is negative 4. I don't like how that looked, so I'm going to tie that up a little bit. Last step. What's the opposite of multiplying by 8? Dividing by 8. I know that makes it too easy. When I set it like that, what's the opposite of multiplying by 8? It gives you exactly what you need to do the question. So you got to recognize what operation is going on. Multiply by 8. So the opposite operation is divide by 8. I don't know if you show it on both sides. Some people show it on both sides like this. You can, whatever's easier for you. And I get x equals negative 4/8. Negative 4/8. It's actually a right answer. I'm teaching my little kids about fractions. And when we're doing fractions and they say an answer like 4/8, I go, good answer. And I don't say anything else about it. But we're supposed to be better than that. 4/8. There's a better answer there. Yeah, 1/2, right? Both the top and bottom divide by 4, so I can simplify that down. How are we doing in time here? Won't you be happy if I don't make it? Wouldn't that be awesome? Half homework on the first day? That's beautiful. All right. Notice I don't care. I'm not going to be commanded by that clock. I'm going to explain it properly every day. I'm not going to rush things.
Would you turn that into a decimal?
You could go decimal. Now, here's the problem with decimals. This decimal's nice. So let me just settle the fraction decimal thing right now from 9 and 10, because your teacher might have not confused you, but it might not have been clear. Why do we want decimals sometimes and we don't want decimals other times? The problem with decimals is the rounding. And some fractions are very friendly. This as a decimal would be fine. 0.5, it's about the nicest decimal you can get. Then there's ones that are not too bad. 0.25, 0.75. If those were the only decimals in the world, we wouldn't even do fractions. We wouldn't even bother. Then the decimals get crazy, right? 0.33333333333. How many do I keep? I don't know. It gets worse. Got your calculator there. Put in 1 divided by 7. 0.142857142857114. Unfriendly decimals. And it's worse than that. Once you round off, see, let's say I take 0.1428 and I round it off to 0.14. If I then multiply 0.14 by 7 to get back to 1, it doesn't get back to 1, it goes to 0.98. Rounding is bad. In this world especially. 100 years ago, what do we care? But that's not what we're about now. We're about these kind of things. And I guarantee you whoever built this didn't round anything off. Now, a Samsung phone, they probably did. They did whatever they felt like. But an Apple phone, they got it right. Without permission by the question to go to decimals, stay with the fractions. Because soon, very soon, it won't be 1/2. It'll be like 1 over x or something like that. And we'll have to know how to handle it. So that's what this is about. So if you don't buy anything I was saying about fractions and decimals right there, okay, buy this. We've got to get used to 1 over 2 so we can handle 1 over x when it appears. Okay. Good question. Check. Check. Oh, I like math questions like this. I hope you like math questions like that. It's nice on a test to be able to go, I'll just check the answer. I'll know if it's right or not. How would I check to see if this is right? And I don't mean go through every line and go, did I do it right? Well, that's good. I like that. But what could you do?
Turn like x in the equation to like negative like 0.5, I guess. So like for the first thing.
If you want to be fancy, what you do is you go, check the left side. Maybe your teacher wrote LS. Maybe you didn't get to left side, right side check. This is how you feel good on the test afterwards. You're like, oh, I hope I did it right. I want my mom to kill me. Yeah? And then you'd sub it in and you go 4 times negative 1/2 plus 2. Yes, I know about the decimals. On a test, would you probably use the decimal? Yes, you probably would on a test to check it. Because you don't have time to be punching these all in. I get it. You might even use your awesome calculator to type this in as a fraction. 4 bracket negative 1 over 2 plus 2. Yes, absolutely. Equals, just to make sure. I love it. I'm not going to do that because I'm supposed to show you that these things are not that hard. Negative 1/2 plus 2 is negative 1/2 plus 4/2, which is 3/2. And 4 times 3/2 is 12/2, which is 6. That makes me pretty happy. Should you do it as fast as me? No! Doing stupid fraction questions when you were still learning to ride a bicycle. But then you check the right side and you go, okay, if x is negative 1/2, the left side is 6. If x is negative 1/2, the right side, oh my goodness, 6 minus 2 times 2 negative 1/2 plus 1. I'm going to try and do both at once. I'm going to show you you can check them this way. But I want to show you what your calculator can do if you buy yourself a good calculator. Try and convince you to get yourself something good. Let me bring up a calculator that works sort of like yours, I think. I haven't tested this year. We'll have to see if it works. Sharp EL531. Please work, please work, please work, please work, please work. It's thinking about it, it's thinking about it. It's coming up on the screen. Oh, there it is. This isn't a perfect calculator, but it's close to the one that many of you have. And if you've got a good calculator, and this is what I was talking about yesterday, about having something that you can rely on to help. It's not about being a nerd. Oh, that's kind of nice too. It's about having something that's like, this helps. Because on a good calculator, you can type it in just the way you see it. You go 6, subtract, not a bracket yet, 2, bracket, another 2, another bracket, and in the brackets, negative 1/2. Now, a good calculator, one of the tests of a good calculator is it shows fractions that look like fractions. Yeah? So then this, when I go negative 1 over 2, see, it looks just like a fraction. Yeah? How nice is that? And then I close that bracket, and it looks just like what I have on the screen. Oh, I forgot something here. I forgot to put the plus 1 there. Backspace, plus 1. What am I hoping for here? 6. Come on, come on. A lot of pressure. Being videoed here. 6. I tried to show you both at once. You have the skills to be able to check these like this. But your calculator, you can just jam it in there with the fraction. You don't have to go to a decimal at all, because your calculator can handle the fractions if you bought yourself something decent. Did anyone order last night? Is it still on sale? Casio FX300 ES Plus. What was it yesterday, Sydney? $14.93? $14.93 for black, $14.93 for pink, $14.93 for blue, whatever you need. Yeah? Do you have any questions about that? Look at that mess. Oh, that is a great question for the first day of 11U math. Things are going to get out of hand here. You got to address the homework. Gots to do the homework to be able to handle these things. This isn't that hard. My calculus people don't think this is a difficult situation because they know what to do and they've practiced what to do. I'll use my basketball analogy again, though. If I was going to teach you to shoot baskets, I stood up here, put a basketball net over there, dribbled the ball a couple times, showed the form, little jump shot, swish. And I looked at you and said, "You got it?" You're like, "Yeah, I got it." I'm going to show you one more time. That's what I'm doing up here. Let me show you one more time. Do. Are you ready to play in the game? No, you're going to get killed. You can't play basketball. I did the least important thing. I'm doing the least important thing up here, teaching. You guys think I'm the most important thing. I'm the least important thing. I'm just like, okay, it's like this. What's next if you want to be a basketball player? Get the ball in your hand. Go shoot 100 baskets. Again and again. You don't do this. This is what some of you do with your homework. You go, what did he say? He did it like this, like this. Whoop. Bounces off the rim, goes in and out, flies out the side. Pretty good. I'm ready. What? You wouldn't do that with basketball. Don't do it with math. Get out there on the line. From over here, from over there. That's what the homework is. Try it in all different scenarios. So then when the game happens, the test, you're like, no problem. 80% from the line, baby. Yeah? What the heck am I going to do here? Look at this. It's not just one fraction. See, one fraction would be bad enough. It's thirds, halves, it's fractions everywhere. I've got it in my back pocket here. I've got the trick. I've got the, is this too old a reference? You tell me. You either laugh or you'll just frown. I have the right tool for this job. The legendary scar. Is that too old a reference? Fortnite? No? See, the game was called Doom 3 when I was a kid. Once you got the grenade launcher, you didn't peek around corners anymore with the grenade launcher. You just, yeah. Does anyone know what it is? What am I going to do to this thing to make my life so much easier? Do I have room to scroll down? I'm going to need a little space here. No, it's not going to scroll down. Oh yeah? Watch this. Anybody using iPad to take notes yet? Oh, you should see my calculus class. Yeah? All iPads to take notes. They'll be a little slower when you're first learning, and then, because they do stuff like this, they're nuts. You should watch them. They run out of space, they just go like this. Yeah? Move it around. Some of them actually take their notes and they put them up into all on one page. They resize it to small little things, and all their notes are on one page. You don't care. Did all that, you future teachers, I did all that to give you time to think. What am I going to do to this thing? I don't know who to point at yet. What do I do to this thing to get rid of both those fractions at once with one legendary SCAR grenade launcher blast? Oh, you don't know. Here's the hint. What's the opposite of dividing by 3? Multiplying by 3. What's the opposite of dividing by 2? Multiply by 2. How can I multiply by 2 and by 3 all at once?
By 6.
6. Legendary SCAR. It's gold. This move is gold, baby. I'm going to put it in gold. For you, if you got another color, now would be the time. This is great stuff. 6. Gold. It's gold. How am I doing on time? I don't even know what time the bell goes. Oh, I can finish this example. Ooh, ooh, ooh. No. Focus, Mr. Todd, focus. Miss Todd, you can just multiply everything by 6? Wisdom, sentence coming. You can do whatever you want to an equation, as long as you do it to both sides. So I got to do it to everything here. So when there's a 6 out front, just like I talked about before, this is distribution. This is why this silly 7 times 10 plus 3 example. So in this moment, you're like, oh, multiply everything by 6. This gets multiplied 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 by 6. Everybody gets multiplied by 6. You go like this. 6x plus 6 over 3 minus 42 equals 6x minus 6 over 2. I don't like rushing examples. But when you're trying to explain a big idea, future teachers, when you're trying to explain a big idea, sometimes you have to rush the details to stay focused on the big idea. I hope you're not sitting there going, what's 6 times 1? That's 6? Oh yeah, hopefully you're just playing along at that point. If you're bothered by I didn't multiply the denominators, ask me that question at the end. It's a brilliant question. And ask me about the denominators at the end. Somebody get it ready. Get it in the holster, ready to ask me. Your response to that should be, that didn't help at all. Mr. Todd, your trick doesn't work. Your legendary SCAR is dysfunctional. And if you send me a text tonight going, okay, I multiplied by 6, but it's not better, all I'll send back is a smiley face. It's great help. A smiley face, like, because what's 6x divided by 3?
2x.
What's 6 divided by 3? In my victorious moment, I let the pen drag. Six x divided by 2? 3x. Negative 6 divided by 2? With one shot, I blew up all the fractions. That's a gold move. Yeah, I don't know how much of that they did in grade 10. It actually is more of a grade 9 thing. But the de-streamed, I don't know, you don't get a chance maybe to get to that kind of stuff. Where does it come from? I wanted to multiply by 3 and multiply by 2 at the same time, so I multiplied everything by 6. Now life's supposed to be better. It's supposed to be better.
Sorry for the interruption. Please join me for grace. In the name of the Father, and the Son, and the Holy Spirit. Amen. We come to you, Lord, before lunch today. Let us be mindful of how our Lord, at a meal, washed his friend's feet in an act of holy service. As the food is about to serve us nourishment, may we also serve one another. May the seal of God's love rest upon this food, and upon this day, now drawing to a close. May we in our gifts of food be under the head of God's will. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen.
Will you do something for me? Finish this, which is a good practice of one more like this. Finish that. Then, your only other homework, you ready? Look at the homework for the first day and see if a lot of those questions you look at and go, oh, I can handle that, okay? I'll finish this lesson tomorrow and you'll have Thursday night to knock down that first set of homework and get us off to a great start. We need a great start. You need to get that first day of homework knocked down. So just look it over. You might be tempted. You might be tempted to do a little bit of it. That'll be good because you'll be getting ready for some homework for the next night, okay? So I'll finish this tomorrow. Then I'll do the exponent laws. Then all that is basically tomorrow night's homework.
That booklet, what questions do we do?
All the questions in the first section.
Okay, I did that. I thought it was good.
Yeah.